What's the shape of the universe? Is it finite or infinite? Does it have a boundary? Some scientists suggest that the shape of the universe could be finite but unbounded. But how can we explain that our observation domain seems internally infinite? The answer might be that our cosmos is a glued manifold, which has repeating patterns that give us an illusion of an endless sky. Suppose that the shape of the universe is finite yet unbounded. Imagine that you have the superpower to walk toward the end of the universe, the edge of the universe. When you get across the edge, then you must come back to the first place you started. Yes, you are like a little ant walking on a donut, which in topological terms we call the shape torus. There's an infinite long path you can walk through since all the edges of the torus are connected, right? Okay, now let's follow that idea. We assume that the universe is a glued manifold. We want to ask a question: how much of the sky do we need to search in order to guarantee that we see a replication or a copy of ourselves? First, let's consider the simplest case, the 2D torus case. Suppose the shape of the universe is a 2D torus and our horizon is one universe length, and we are at a corner of the universe. Then the maximum search angle is 90 degrees, right? We can see many copies of ourselves. Each dot represents one. Then if we could see a little bit further, we could cut the angle in half and still see a few copies of ourselves. And if we get further and further, the angle gets smaller and smaller. It turns out the minimum search angle is always right there. Mathematically, we can calculate the minimum search angle as theta equals arctangent 1 over square root d squared minus 1, where d is the horizon distance or the universe length. We use the MATLAB software to create a lattice grid and write a code script that matches the 2D torus equation we found. The second part of the project is assuming that the universe has the shape of the 2D Klein bottle. I circled the Klein bottle picture in red here. It has a very different topological properties than torus. As you see here, if you are a little shape guy facing and walking toward the edge of the Klein bottle, you'll come back as upside down and flip left and right. In 2D Klein bottle, the minimal search angle problem is actually way more complicated than the 2D torus case. We approached the problem by using the MATLAB initially, but it didn't work well due to its complication. Then we changed to search the angles by hand using pencil and paper and analyze the pattern carefully. We're still in the process. Here are some pictures I drew for the 2D Klein bottle case. By last semester, we finished the preliminary numerical case for the 2D Klein bottle shape, and we find an interesting bifurcation case as we reach the universe length to 5. Okay, so finally, what's the significance of the research project? As cosmologists seek patterns in the arrangement of galaxies and cosmos, well, we try to understand mathematically the connection between geometry and the behavior of the physical universe. Thank you so much.